Hey guys, this is going to be example 1 in section 3.2. Now, this example is pretty straightforward. If you're looking for a linear function, you're looking for any line that is non-vertical. So these should be pretty easy to see. Okay, is this a linear function? I apologize for that bell. No, this is not a linear function because it is not a line, period. So this is not a linear function. This one, we see it's a line and it's not vertical. So this one is a linear function. Now, I want to go over something that you can see in this picture, but it's what really makes sense as we go through. Whether you're looking at a picture, an equation, or points, when you're looking for a linear function, you are looking for what's called a constant rate of change. What a constant rate of change is means it keeps going up or keeps going down by the same amount over and over again. When we look at this one, right now you can see it goes down, then it goes up. This cannot have a constant rate of change because the change, in other words, changes. If you look from here to here, this went down 3 over 1, and then this went down 1 over 1. Your rate of change is how far you go up and down compared to how far you go left and right. So what you're going to hear me say a little more technical later on, we're going to call it delta y, delta x, or your rise over your run. That's probably the most common way you've heard it right now is rise over run. So the rise from here to here is down 3. The run is 1. Our slope from here to here would be negative 3 over 1. When I look from here down 1 over 1, this slope would be negative 1 over 1. You see we have different slopes. You have different rates of change. So this cannot be a linear function. Now, you can look at the picture and say, okay, it's a line. But I want you to see the rate of change in this picture because it's really going to help later on when you only have points. So when we look at this line, if we start from this lattice point, we go up 2 over 1, and then go to another lattice point, up 2 over 1, up 2 over 1. As we follow the line, we can see that we constantly go up 2 over 1, up 2 over 1. So we have a constant rate of change. Now, the other part you can see is looking from this point here to this point up here. You can also say we go up 4 over 2. But hopefully, if you think about fractions, which is how we're going to represent slope, it is going to be a fraction, or in other words, a ratio. These are terms you're supposed to already know, but a ratio is just a fraction. It compares something in the numerator to something in the denominator. Here, we're comparing your rise to your run. You know you have a rise of 2 and a run of 1. So our constant slope is 2 over 1. 2 divided by 1 is 2. But watch when I go from this point to this point. I would go up 4 over 2. Well, we get the same number. 4 divided by 2 is the same as 2 divided by 1. That's why I want to think about rise over run in terms of ratio, and then always reduce your fraction. They're going to give you problems where you're going to see the same slope, but written differently. It can be written as 4 over 2. It can be written as 2 over 1. It can be written as 2. As long as those are all equivalent, then we have a constant rate of change, or in other words, a constant slope. Now, I know for these two examples, I got a little bit more complicated than what you're really asked here, but you'll see in the next couple examples, you'll appreciate that I went over it as long as you paid attention in this part. So again, looking at A, this graph is not a line, so the function is nonlinear. See how easy that part is? This graph is a line, so the function is linear. And you should be a little careful on this. It is a non-vertical line, so the function is linear, okay? So hopefully that gives you some insight to start off this. If you're given a graph, you just look and see if it's a line. But now we use the graph to get some concepts about what we're going to see in the next couple examples. So go over this and then try your monitoring progress, and then I'll see you in the next examples. Thank you.